Okay, for number one, you were told to find the reference angle of 255 degrees. So to find the reference angle, you're always going to form the angle with the x-axis. So here I put my terminal side over here at 255 degrees, which is between 180 and 270 in quadrant 3. And then when you subtract with 180 degrees, it's a 75-degree reference angle for number one. So, so far, when we've been finding reference angles, I have been having you guys only find 30, 60, and 45-degree reference angles just to help us with evaluating. But just so we're aware, moving forward, reference angles could be any angle between 0 and 90. Number two, finding the reference angle of 170 degrees. Again, the terminal side here in quadrant 2 between 90 and 180 degrees, and then you subtracted and formed that angle with the x-axis. So 180 minus 170 gives us the 10-degree reference angle. For number 3, we're going to find one positive and one negative coterminal angle with negative 460 degrees. So we want to remember coterminal means that they lay on the same spot on the unit circle. So you're going to be adding and subtracting one full circle, which is 360 degrees. So to get my positive coterminal, I have negative 460 degrees, and I'm going to add 360. So I'm really subtracting and keeping the sign from larger number. I get negative 100. Well, negative 100 isn't a positive number, so you're going to add 360 again, and we get 260. So remember, if you add your 360, it's still negative, then you just add it again until you do get that until you do get that positive number. For our negative coterminal angle, I'm going to take my negative 460 and subtract 360. These have the same sign. I'm going to add, keep the sign. I get negative 820 degrees. So these could be your answers, but just so we are aware, there are lots of different answers you can get for these, as long as you are getting positive numbers adding 360 and negative numbers subtracting with 360. So just so we know, negative 100 is actually a negative coterminal angle. So you can actually use negative 100, but negative 820 works as well. Number 4, you are converting to radians. So remember, when we're converting degrees to radians, we want to take out degrees. So we're dividing out 180, but multiplying in pi. So we want to memorize this. You multiply by pi over 180 every time you convert to radians. So I put a 1 underneath my whole number and multiplied across my fractions to get 100 pi and 180. So the degrees did cancel. And then the zeros cancel one top and bottom when you divide out 10. And then I simplify again by dividing 2 top and bottom, and I get 5 pi over 9 is my answer. Number 5, I'm going to evaluate cosine of 210. So I'm going to follow my steps. First step is to find the reference angle. So what I did was I graphed the 210. I plotted 210 degrees, which is here, and found the reference angle, which we subtract with 180, and I got the reference angle 30 degrees. So that's my first step. My second step is then to label the adjacent and hypotenuse. So you know that this is always a reference angle. Created is going to be next to the origin. So adjacent is going to be here, and hypotenuse is here. We memorize that opposite or across from the 60-degree angle, this side length is always going to be square root 3. It's negative square root 3 because we're going to the left on the x-axis. And then we memorize in the 30, 60, 90 that the hypotenuse is always 2. So my fraction is negative square root 3 over 2 for cosine of 210 degrees. Sine of pi over 4, we feel more comfortable if we see pi over 4 in degrees. So if you use your unit circle, 45 degrees is what pi over 4 means in degrees. So then I follow my same steps. I plot 45 degrees. Then I find the reference angle. If I'm in quadrant 1, I'm subtracting from 0 at the x-axis. So I have a 45-degree reference angle. They're asking me for sine. We need the opposite side and hypotenuse. So we want to memorize that the legs or the sides across from these 45-degree angles are always going to be 1. So over here for opposite of my reference angle, it's positive 1 because this side of the triangle goes up. So positive 1, and then we want to memorize always in the 45, 45, 90 in the unit circle. Square root 2 will always be our hypotenuse. So opposite over hypotenuse is going to create my sine of pi over 4. I get 1 over square root 2, and then rationalize, and my answer is square root 2 over 2. Number 6, we're going to talk more about when we review on Friday. They're asking, when are you going to have sine of an angle greater than sine of another angle? So that's just asking me, where am I going to have sine that is greater? So what we want to understand is that in quadrant 1 and 2, that's where our sine is positive. The opposite sides are going to be opposite, or those y values are positive. So then down in quadrant 3 and 4 is when our sine is going to be negative, because these opposite sides go down and they're negative. So we want to understand that sine is going to be greater when we're in quadrant 1 and 2 than when we're in quadrant 3 and 4. So it's greater in quadrant 1 and quadrant 2 for sine. All right, last one, number 7, we're going to find the missing lengths. So they gave us 12, y, and x. So what I did first was I highlighted my smallest side, because the smallest side is going to provide us the rules. And then I wrote in the rules. From the short side to that longer leg, you multiply by square root 3. From the short side to the hypotenuse, you're going to multiply by 2. So there's no rule to get me from 12 to x, so I'm not trying to get to x. I have to go to y first. So if I'm going to go backwards to y, I'm going to be dividing by square root 3. So I showed that work over here. 12 divided by square root 3, then I rationalize, then 12 divided by 3 gives me 4. So y is 4 square root 3. So my short side's 4 square root 3. So if I want to find my hypotenuse, I take that short side, 4 square root 3, and multiply it by 2. And that's what I showed right here to get 8 square root 3. So if we're watching this, it's because my other video, I just had the worst technical difficulties. So just be aware, if we're watching YouTube, the next video, there's a little bit of some technical difficulties, but just concentrate to the best of your ability, and we're definitely going to go over this stuff when I see you Friday.